Hello, night owls, and welcome back to the Midnight Science Hour. Tonight, we're delving into the fascinating world of chemical engineering, specifically a groundbreaking new optimization technique that could revolutionize how we produce and utilize hydrogen fuel. I'm your host, Adam Stone, and we're diving into a recent paper from a team of researchers at Lawrence Livermore National Laboratory and Carnegie Mellon University. Their work focuses on something called multiscale optimization. Imagine designing a car engine. You wouldn't just think about the individual parts, but also how they work together as a system. That's similar to what these researchers are doing with chemical processes. They're looking at different scales of a process, the tiny interactions between molecules, the way chemicals flow through a reactor, and the overall economics of the whole operation. Now, optimizing these different scales independently is tricky. The models that describe each scale might use different kinds of math, and it's hard to put them all together. That's where their clever solution comes in. Surrogate models. Think of a surrogate model as a simplified version of the complex system. It's like a map. It doesn't show every single detail, but it gives you a good enough representation to get around. In this case, they used something called linear model decision trees. These are machine learning tools that build simplified models of the process, which are easy to use in optimization. This is because these surrogates are easily translated into mathematical models that computers can solve. They tested their technique on something called formic acid dehydrogenation. Formic acid is kind of like a hydrogen storage tank. You can pack a lot of hydrogen into it, then release it when you need it. The researchers wanted to find the most efficient and cheapest way to make this process happen. What they found was remarkable. By optimizing the different scales of this chemical process at the same time, from the molecular level all the way up to the large-scale production costs, they achieved a 40% reduction in cost compared to optimizing each part independently. That's a huge win. So, what are the implications? This new approach is not limited to formic acid or hydrogen production. It could be applied to all sorts of chemical processes, leading to major improvements in efficiency and significant cost savings. In the quest for cleaner and more sustainable energy sources, this is a giant leap forward. However, like any scientific breakthrough, there are limitations. This approach relies on having a lot of data to train the surrogate models. It also may not be perfectly accurate outside the range of the data that was used to train it. But this is an exciting step towards more efficient chemical processes. That's all the time we have for tonight. Remember, science is always evolving and will continue to bring you the latest breakthroughs. Tune in next week for another installment of the Midnight Science Hour. Good night and keep looking up.